Hello everyone, now for our next talk, introducing PIP Services, a new open source toolkit by Eugenio Andrieu. I hope I said that right.
Okay.
Take it away, Eugenio.
All right. Hello everyone. What we're going to talk is about this PIP Services. That is a new open source toolkit that is available since June this year. For the ones that wonder about the name, it has nothing to do with the pip command in Python. It's just a historical case that they put that name. So what we are going to do is to see first an introduction on this toolkit. Then we will see a demo that is just a simple hello world demonstration. And the last part, it will be, we will talk about the principles behind and the architecture of this toolkit. So the first part is the introduction. So what is PIP Services? And basically it's a toolkit that presents a collection of ready-to-use components. It is used to, or it was aimed to create it to build microservices, but it's not restricted to that. You can use it for monolithic systems as well. It has a large number of reusable components, which include loggers, tracers, performance counters, distributed caches, distributed logs, credential store, etc. And this is also quite interesting. It supports 6 programming languages, which are at present .NET, Java, Node.js, that is JavaScript, Python, Golang or Go, and Dart. So this system has a page that is www.pipservice.organization. It was created by a company called Enterprise Innovation Consulting. And it has an MIT license, and it was launched in June 2021 as an open source. However, they started building it in 2015, I believe. So for the ones who are interested, this is the page. It got for different languages. And here it shows about the different building blocks, languages, and components. It had also a blog where and you can communicate and be part of this group through Discord. So this is let's go to the second part, that is our demo. For this, we will use we will create a small application that is prints hello world on our browser, and the main characteristics are that it has a controller, and we will use a REST service. These are components from the PIP's toolkit. And we will use a container. We will see later the container manages the whole life cycle of our components in an automated manner and reads from a config yarn file, and it creates the components through the use of a factory. So let's go to our example. The first thing that the example is part of it's already there in the toolkit, and whoever wants to do the example, to reproduce it, they can install the requirements using this file that is downloadable there. You can download it, and with the pip installed, you can get all the necessary tools. So the first thing that we do is our controller. What is a component comes here? A component is simply a class with a defined constructor. In this case, in the constructor, we simply define our default name that will appear in our in the result screen when we don't put any name. And here we start to see what we use. There are certain specific method that we use, like configure method, to configure our component. And we will create a method called greeting that basically we will define. If we got a name, we will say hello with that name. If we don't have a name, it will be hello with PIP user. Following this, we will create our REST service. For that, we will be looking at a few things that come from this toolkit. The first one is our REST service that is we call from this RPC module. And the second one that's important is the descriptor. The descriptor, it's basically a locator that we use to configure our components. We will see later on how to configure the components. So then we created our new class that is based on this REST service class that component. And we create our constructor, and then we use a set of methods that are defined in this REST service, that are the set references is the first one, but basically it's a link to all our dependencies. In our case, we will define it at the controller. And then we will register this our REST service, and we will call it calling the root calling it greeting. And we will here we also define our greetings method where it calls the the method that we defined it here before in our controller. So basically, these are the two components that we are using. Now, to run these components, we could use, we could create a class, the whole manually create the whole procedure, create a class, and run each of the methods manually. But for that, we will use another component that this toolkit presents. That is it is a container. For that, first we will create a factory, and we will create a hello world factory. That again we use the descriptor that we used before as a locator, and we import the factories that we have. In the factories, we just need to register each of the elements. In our case, we got two components, which are the controller, what we defined before, and our service, REST service. For then, we will create this container. The container in this case is an executable container. There are several types of containers that present these toolkits, two types of container, but this one will allow us to execute our life cycle of the whole system. And here, what we need to define is our configuration file. And then we add each of the factories that we defined before. That was for the service, and then also for the RPC for our REST service. Let's take a look at our configuration file. And here is where it comes quite easy, and the importance of this toolkit. In the configuration file, we saw about the descriptor that basically has a syntax that it needs to be understood, but it's quite flexible. And sometimes we can put here asterisks or stars. That means that we can have more than one definition for the same container and give us the flexibility to choose between different components. And also, each of the components, we are going to create a console logger where our messages will be displayed. And this is our controller that we defined before. And there, this is our REST service. For example, here I just added, we could, for example, add very easily, it's in a copy-paste, a Postgres database or any other persistent component. And if we, instead of doing that, we wanted to add whatever, a data log or let's see, for example, Mongo, another we don't like, we prefer to switch just by setting the new, basically it's a copy paste and putting writing the new settings, we get the new component, and we need to add it to the factory, and creating our code in a very fast manner. So then we just need to run. To run it, we call the run method. That is the method that comes from this process container. The process containers got the run method. Once we run, we will get, we said that we have a console-based logger. So here is what we have in the message saying that the service has been opened and the controller has been started, and we can stop it with Control-C. And using here the Jupyter notebooks, because I thought it was easier for presentation, for the presentation, but you can, usually this one is different files, no? Each of them, it will be a different file representing one of these microservices, each of the components. So if we see the result, this is once we run, we will see here appear something that says hello world. Is as we said, we put no name here. It appears PIP user, that was our default name. Or we can also put another name, like for example, John, and it will appear on the screen. Now, one of the advantages of this, we say that this is done, as you can see, in Python. However, and this is, I will explain it later on, in the third part of the chat, one of the advantages is that this thing is what they call symmetric implementation, which means that the structure in the 6 languages that this toolkit is based is very similar. You can see here, for example, this is with JavaScript, with Node. And basically, we use the same method. We use also a descriptor. For example, this is for the Hello World factory, but it's similar for all the other components. So we got the descriptor. We use the method register as type, which is basically the same method that we use here. Register as type. And we got the controller, the descriptor, and the aim of this symmetric implementation, one of the advantages is that you need to switch from one language to the other, or it's very fast because you already got the structure in the previous language, and by using the same function from the toolkit, you can move from the .NET to Java, or to Python, or to Node.js quite easily. So basically, this is what is the example that I am trying to show. So this example, you can find it in for the other languages in any of these links. You just go to the GitHub, and there you can find the code and run it by yourself if you're interested. It is available in Python, in Node.js, in Golang, and in Dart. Also in .NET. So let's go now to the last part of our chat, and it's the principles behind and the architecture of this system. And the principle behind is the main one is this symmetric implementation idea. And what that means is that for every programming language that is implemented, this toolkit, I mean these 6 languages, there is a common set of classes, methods, and method signatures. That's what we saw before. The symmetry can be seen pretty easily when we see 2 different code. This one here is in Python, and here we got the same version of the same code, but in JavaScript. And the same we could see if it is in .NET or Dart or Golang, etc. We could see a very clear symmetry, and this symmetry is what allows this fast transfer from one language to the other, or even to coordinate if you are doing microservices in different languages at the same time, according to your requirements, business requirements. The architecture of the system. So what we said is that this system has base in 6 languages available: .NET, Java, Node, Python, Go, and it's also missing here in this figure. Is now they have added recently Dart. So you can use this toolkit in any of these languages, calling all the components and assembling your own components. And because it is open source, you can also create new components and add them. They are very easy to create. And then you have a common set of structures that is what is called the commons module. That basically are primitives that you can use to create your own components, new components. And then we got another layer that is a set of components that are available there. Some of them are for persistence, for data management, etc., communications, etc. Some of those components are more specific, like what we saw, the container that we use to manage the whole life cycle of our component in an automated manner. And then we got the data component, for example, that brings us the capacity to to manage data, which is one of the main components in elements in our programming to manage our data. Then we got aspects to communicate in a synchronous manner and asynchronous manner. And then finally, we got more dedicated components like Azure, AWS, MongoDB, that we saw that we can add Memcache, Redis, Elasticsearch, Search, and etc. Many components, and they are adding components all the time. So the toolkit is becoming more and more comprehensive. And this capacity is what brings the idea behind this toolkit, that is to create long-living code. Long-living code means code that passes the test of time. In other words, if we create an application now, that application is not obsolete in 2 years, but it can last 5, 10 years or more. And for that, we have adaptability. And if tomorrow appears something different that replaces MongoDB, a new database or something, you can create that component and basically plugging in and plugging off to replace your MongoDB database persistent for this new persistent, new database persistent that appear in the market. So an important concept behind this is the component's life cycle. So each component has a life cycle that consists of 8 stages. The first one is the creation. Basically, this is one when we create a new instance of our class or our component. We say that components are classes with a specific constructor. The other stage of the life cycle are all defined by specific interfaces. For example, the configure stage where appears you configured your component is governed by the iConfigural interface. Similarly, the set references step where you define all the reference to your dependencies is defined by the iReferenceable interface. Each of them has a specific method, like, for example, the iConfigurable interface has a configure method. That all these interfaces are basically defined in the same way for all the languages, and that gives that symmetry that we talked before. Then we got the iOpenable and iClosable interface. Both of them they work in coordination. If you open, then you have to close. And basically, to ensure that, particularly with the iClosable, that when you close everything, it's clean. In those 3 dots there, it's where you do all your business operations that you could define. For there are also 2 interfaces. One is the iNotice and executable, and the notifiable interface. And then you can close your component once all the tasks have been done, and set the references. In other words, you close the links to all your dependencies, and finally you destroy your component. Basically, you clean the status of your application. So why PIP services? And here it comes the idea behind the creation of this system. That is to create a long-living code. As we said, long-living code means we want to create code that we don't have to replace it in 1 year or 2, because new technologies or new platforms may make this our application obsolete. And for that, we need to have several properties that this PIP service has. First is cross-language and cross-platform. Means that even if it appears in new language, it can be you could create your own languages. Let's say, and you following the same patterns, and you could create language number 7. It's comprehensive, as we saw. It includes many technologies available on the market, and it's very easy to add new technologies, to create new components. It has an incremental approach to development, in other words, and that's very easy, very important. Perhaps if you want to replace an old system, you don't need to spend a year or 2 creating a new system and then replace. You can do it in an incremental manner, where you replace part of the old system. Let's say even if you want to migrate from .NET to Python, you could create a plan with step-by-step where you're replacing in an incremental manner the different microservices. And production-grade code is code that it can be used in production. High development productivity. This is also very important, because what happens is that if you train also a developer in this system, it doesn't take long, and then it can specialize. And when appears a new technology, or you want to replace, let's say that we had Postgres and we want to move to Mongo, and then we decided to move to Cassandra and then to another database. A developer with can immediately, in a very fast manner, can really be very productive and replace and create all those updates. And that also goes to the last one, that is architectural flexibility, where as we said, we can change platforms and even add new languages, etc. So the idea behind this long-living is adaptability to the new environment. And the second part is because it's easy to train and to replace, basically almost on a plug-in, plug-off, just configuring the system, is we can do it in a very short time. In other words, our development time is reduced. They claim that it is substantially reduced, up to 6 times reduced compared to other ways to develop microservice systems. So this is the end of the presentation. I got another, I don't know,
Do you want to share some more things?
No, it just, there is another tutorial that so it can be seen.
Yes.
I created it's 2 components. I created myself a component A and define. I just used, for example, in the life cycle, the iReferenceable, the unreferenceable, iConfigurable, etc. interfaces. So I define all my methods, and I created another component which I call component B. That is, I use it as a dependency. And then I just use again a logger. And here we can see, for example, if I would have done everything manually, it's possible, but it's quite long. Right. Now, the system is just a demo, so it only produces messages, login messages. But if I use my, so this is doing it manually, creating the component, or opening, configuring, executing my business tasks. In this case, was just to print, sorry, to create an error that I created an error here that is just to produce an exception. But if we do it with the container and the factory, this reduces to very few lines of code. And this manages all our in an automated manner. So that's it from my side. I don't know if I need to stop sharing now.
That's fine. Thank you very much, Eugenio. There's a few questions, all from Ivan. I think he enjoyed the talk. I found it very informative. Thank you. So the first question from Ivan Blazik. Is it fairly simple to create multiple services and have them communicate with each other using this system?
Yes, it's pretty simple, and you can create it in different languages. Let's say, for example, I have seen, for example, a system that they created, digital twins, where some of the microservices were in Go and another were in Java. And even what is very nice is the way you can manage to the exceptions, the errors, how to communicate between the different languages and manage the errors in a coordinated manner. But that is the idea. That's the idea, even to replace. And they can use, for example, a facade, where you create first your structure, and then you communicate, and then you can transfer. Let's say you want to migrate from one language to the other, or you want even to communicate with the different language in the microservice.
The next question, you mentioned containers. Would you be able to use something like Docker with this?
Yes, there is a component for localization for most of the platforms. If you go, let me show, can I share again?
Yes.
Share screen. So if you go to the documentation, let's say this is per language. So let's go to Python. You can see here that there are several, and there is even there is a tutorial that is for Dockerization. Let me get toolkit recipes. Dockerization. So here, if he wants to read and how to, it's step by step, define how to Dockerize the microservice.
Okay. Thank you. And then lastly, would you be able to share some of the links in the Discord chat?
Yes, 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 yes.
Let's
They
do
can
that.
all the things are there also in the web page there that they have. The web page is just PIP Services, and then it's the .org, and then you can get there. And everything is available also via GitHub. So they can take it, and it's as open source. So it's something that they want to modify, and they are very open. If someone wants to also to contribute, and they are very open for new. They got their Discord is like a chat link for them, so you
Yes,
can also contact.
I can help you and see if we can get some links through there afterwards.
Yes.
Ivan speaks for everyone. Thank you very much. Very interesting. I was wondering what caused you to create this company and create this problem? I'm a complete beginner, but what was the pain points that you were trying to
I'm not
address?
the creator. I'm not the creator. I know the creators. There's a company it's in United States, and it's a Russian or Ukrainian person. Most of them are Eastern Europeans, and they started to work in microservices. I think for IoT and Internet of Things. They started creating this toolkit, and then they thought that they had been quite successful with a few clients. I know they got clients in Australia as well, and the States, mostly English-speaking countries, and they decided to give it open source for whoever would like to use it. No.
Very good. Okay, I don't see any further questions immediately. So I just want to thank you again. That was very interesting.
Okay, thank you.
Great stuff. And we'll see more discussions in Discord and on GitHub, I'm sure.
Okay, thanks a lot.
Okay. Thanks.
Okay.
We'll end the broadcast there. Thank you very much.